Hey guys, how are you all? Myself Swapnil Sir, and I hope you all are doing well. And welcome to yet another complete lecture series on mathematical logic chapter. Already we have started solving previous year questions and revising the topic from last few days. So if you are interested to see the previous year videos, previous year questions, and along with the topic, you may do check it out into my playlist. So in my today's video, we are going to understand some of the important concepts from the mathematical logic chapter. Okay, so as board exam is coming closer, so we have to get ready for our board exam. So now see that mathematical logic, it is the completely scoring based chapter. Okay, so it gives us a very easy mark. So only we need to know only some few certain topics. Okay, and these are very much easier. Okay, so they don't have anything difficult or any other formulas. We don't have anything in mathematical logic, just a logic based chapter. Okay, so if you can see differentiation, integration, there are needed formulas, trigonometrical concept, but in a mathematical logic you will get the near about 8 to 10 marks question, and there is no need to use any formula, only the logical based questions are coming. So if you are properly prepared with this chapter, you will get the out of marks which carries for this chapter. Okay, so myself Swapnil Sir, welcome to yet another time. Okay, so let's get start our today's lecture. We'll start first of all the basic concept about mathematical logic, and then we'll move for the further example which is from the previous year question from board exam. Okay, so before I start mathematical logic questions on mathematical logic, as I wanted to explain here statement pattern, truth values of a statements. After that converse, inverse, contrapositive for statement. After that logical circuits, logical circuit, conversion of a logical circuit into the symbolic form into the logical circuit. Again after that truth table. These are all important topic in our mathematical logic. Okay, question will only coming based on these topics. Okay, so do prepare this topic properly. So already I have uploaded detailed videos on these topics. So if you are interested to see, you may check it out. Okay, so let's start our first part. So statement. Okay, what is mean the statement and statement pattern? Okay, so in mathematics we have some of the statements that can be used like a regular life. Okay, but in mathematics we take it's a different abbreviation to read this sentence. Okay, so in our regular life we use if and then, and in mathematics we use as the conditional statement. Okay, so meaning it will remain same, but the only names are changed. Okay, so only these connectors we have to understand it here properly. Okay, now a truth value of a statement. After that truth value of a statement, what it says, truth value of statement. Okay, truth value of a statement. Okay, now tell me the meaning for truth value of a statement. Now let me explain. Truth value means the whether the value of a statement it goes to positive or negative. Like the value for statement it is a true, or the value for statement it is the false. Okay, so we consider as the truth value for our statement. Okay, so whether it is a true or false, using both of them we can find the truth value for our statement. Okay, so this one is the truth value for our statement that we define whether the statement are true or false. Okay, using the truth value for a single statement, we can easily say that the statement is a true or false. But when it comes up as a part of a two different statement, like a three different statement, that time we have to apply probable chances to get the truth values. Okay, like a probable chances means if I consider the two statement, like consider the first statement as a P, second statement as a Q. Okay, now truth value for these two statements, now see that we have to take it we have to take both of this truth value combined here. Okay, for this combination we consider first truth value as a true. Okay, maybe first statement it can be true, next statement it remain true. Okay, if we consider first statement it is a true, and then second statement we can take it together as a false. Okay, these are the possible chances that how we can take the truth values for two statement together. Okay, but always remember that we don't have to repeat these again. Okay, so yeah, I have considered first truth value, first statement true, second statement true. first statement true, second statement false. Third, first statement false, second statement true. Okay, and fourth, first statement false as well as second statement false. Okay, these are the truth values for two different statements. Okay, so you may get the in your question paper like using three different statements. So that time you also have to convert first statement P as a 4 true, 4 false. Okay, second statement Q as a 2 true, 2 false, 2 true, 2 false. Okay, and last statement Q as a 1 true, 1 false for every statement differently. Okay, so I'm expecting that it is easier for understanding the truth value for our statement. Okay, now next part of our here statement pattern, next part here. So we are going to learn logical connectors. Okay, logical connector means and, or, if, then, if and only if, and not. Okay, these are the logical connector which we used in our daily life. Okay, but in mathematical sentences these words are having same meaning, but we cannot take copy these words in our mathematics. So instead of that and, or, negation, implication, implies, if, then, if and only if, we have taken some another words. Like if we have and word, we consider it as the conjunction. If we have odd word, we take it as the disjunction. Okay, if we have implication, that means we consider it as the conditional statement. Double implication means if and only if, we consider it as the biconditional. And last, not, means we consider here as the negation. Okay, all of these statements we are going to use here in a subsequent examples. Okay, so that one is easier. Now next part here, we need to understand the statement pattern, the converse for our statement, inverse for our statement, and contrapositive for our statement. Okay, so this 3 to 4 part which is very much important, because every year I found in my previous question papers they're all everywhere we have questions. Okay, if you have statement P implies Q, then it's a converse. How can we write the it's a converse? Okay, now let me explain here. If I consider statement as a P implies Q, now see that P implies Q means if I do something, then it happens something. Okay, that means I consider two different statement, as a first statement as a P and second statement as a Q. Okay, so these are the two different statements here. Don't get confused by using P and Q. P and Q are the two different statements. Okay, so using these two different statements, we have to find out the converse, inverse, and a contrapositive. Okay, so if we have statement P implies Q, then it's a converse. What it says that converse, what it says that go for the reverse direction. Reverse direction means we have to go for the Q implies P. Okay, it's a converse. Okay, if you have statement P implies Q, that means we have to find out the converse by using Q implies a P. Okay, similarly for inverse, and contrapositive. For inverse, we consider not P implies not Q. That means negation of a P implies negation of Q. Okay, just try to understand it by using symbolic form. We are going to continue some of the examples based on this mathematical logical symbol. Okay, then ideas will be very much clear to you all. Okay, after that, contrapositive, it says that if we take negation of a Q implies not P, then we get the contrapositive for our statement. Okay, now whenever you get the question like in our board exam, find out the converse, inverse, contrapositive. In this condition, what you need to do? First of all, convert our statement into the symbolic form. Find their converse, inverse, contrapositive in itself a symbolic form. Okay, and once you get the symbolic form, then return these values back, so you will get the required statement. Okay, now let's get start our today's lecture with the previous year questions. Okay, those are the basic concept we needed here for our today's lecture. I explained it already. Okay, and those are coming new. I will explain while we are solving the examples. Okay, now let's start it our today's lecture with the previous year questions from board exam. Okay, now we can see that question asks in March 2018 for the 3 marks. Now see that questions are quite easier and easily help us to make our score higher in our board exam. Okay, so don't forget to solve this question first. Okay, now see that we have to find converse, inverse and contrapositive. What we want? We want here converse. Okay, after that inverse and contrapositive. Okay, so we want these 3 statement: converse, inverse and contrapositive. Okay, so we have to find out these 3 statement. Okay, so first of all, what we do, try to convert our given statement in the different form of a different form of a statement. Okay, now we can see here our statement. It says that if an angle is a right angle, okay, if an angle is a right angle, then its measure is 90 degree. Okay, so what we have statement here? If angle is a right angle, then measure is a 90 degree. That means our statement connected using if and then 2 different words. Okay, that means the connector here as a implication or conditional type of the statement. What we have here? Conditional type of the statement. So first of all, separate these 2 different statement and take it out from the conditional statement. Okay, so we have conditional statement here. If an angle is a right angle, then its measure is a 90 degree. Okay, so consider first statement as a P. Statement P I consider here angle is a right angle. Okay, so we have first statement angle is a right angle. Okay, we have first statement angle is a right angle, and second statement, then after then we have second, its measure is 90 degree, then measure of angle is 90 degree. That means next statement, measure of angle is 90 degree. Okay, so we have 2 different statement. First statement, it says that if angle is a right angle and then its measure is a 90 degree. Okay, so as per the converse, inverse, contrapositive definition, I have converted one statement into the 2 different form of statement. So if and then, that conditional statement I taken it out from there, so I got extracted 2 different statement. Okay, now see that I have statement P and statement Q here. Okay, so first of all, we want the converse from our statement. Okay, so what we have here, first statement pattern, if an angle is a right angle triangle, then its measure is a 90 degree. Okay, so first statement we have in the form of if and then. Okay, so that means P implies Q. We have statement P implies Q. That means if an angle is a right angle triangle, then its measure is a 90 degree. That means angle is a right angle triangle. We have statement P and measure it is 90 degree. The statement it is here as a Q. Okay, so our given required statement here P implies Q. Okay, for finding converse, inverse, contrapositive, we have to apply the definition from the converse, inverse, contrapositive. Okay, so if a statement is a P implies Q, first statement if we have P implies Q, let me change the color. We have first statement here P implies Q. Okay, okay, so if we have statement P implies Q, then its converse say that second means its converse gives us Q implies P. Okay, this one is the statement. Okay, this one is a statement P implies Q and its converse gives us Q implies P. Okay, now let's write the converse of our statement. Okay, first converse of statement is a Q implies P. Okay, converse of a statement, it gives us Q implies P. Now what we do here, substitute the values from our statement. Our statement gives us if angle is a right angle triangle, then it is a angle is having value 90 degree. Okay, now if we have P implies Q, then its converse say that it's the statement is a Q implies P. Okay, that means if measure of angle is 90 degree, then angle is a right angle. So what will be the statement here? If measure of angle is 90 degree, then if measure of angle is 90 degree, then angle is right angle. Is a right angle. Okay. Now see that how it is easier for finding the converse of our statement. Okay. So of our statement gives us here, if angle is a right angle triangle, if angle of a right angle, let me read the statement again. If an angle is a right angle, then its measure is a 90 degree. Okay. And its converse say that if measure of angle is 90 degree, then angle it is a right angle. Okay. So this one is the converse of our statement. Now we want here next as the inverse. Okay. Let's go for the inverse. Now when we have statement P implies Q, then it's a inverse. What the inverse of our statement is, says that we have to go for the negation of a P implies negation of Q. Okay, that means not P implies not Q gives us the value for our inverse. Okay. Okay, statement we have converse Q implies P, then inverse of our statement negation of P implies negation of Q. Okay, this one is the inverse of our statement. Okay, now let's write the inverse of a statement. Now negation of a P means the negative form of a statement P. Okay, so if statement P is there, then its negation gives us a not P. Okay, so we have to introduce here not word in his suitable place. Okay, now let's write the negation of a P first here. So P statement is here, angle is a right angle. Okay, then negation of P, it says that if angle is not right angle. Okay, if angle is not right angle, if angle is not right angle, then we write this one as then negation of Q. Negation of Q means opposite statement of the Q. Then measure of angle is not 90 degree, then measure of angle is not a 90 degree. Okay, so this one is our negation of P implies negation of Q. That means we have statement angle is a right angle and then measure of angle is a 90 degree. Then its inverse, it says that go with the negative meaning of our first statement implies go with the negative meaning of our second statement. Okay, this is the inverse of our statement. It says here defined here. Okay, this ends here inverse, this ends here converse. Now we have left here with the value of a contrapositive. Okay, okay, now we have statement P implies Q, then it's a contrapositive. It says that negation of a Q implies negation of P. Okay, it's a contrapositive, says that negation of a Q implies negation of P. Okay, so when we have statement P implies Q, we write it's the negation as a negation of Q implies negation of P. Now substitute the value for Q and P from our statement. Okay, we have statement angle is a right angle. Okay, and then negation of a Q, that means if angle we have statement angle is a right angle triangle as a statement P, and the statement Q measure of angle is 90 degree. So negation of a Q means if measure of angle is not a 90 degree, that means it comes as a negation of Q. Okay, let me write here as a contrapositive. Okay, So contrapositive is defined as negation of Q implies negation of P. Okay. So negation of Q means need to introduce not here in our statement Q. So if measure of angle is not 90 degree, if measure of angle is not 90 degree, then so if first statement is negative, then second statement also negative. So if measure of angle is not 90 degree, then angle is not a right angle. Okay, so negation of Q implies negation of P, then angle is not a right angle. Angle is a not right angle. Okay, this one is our contrapositive of our statement. Okay, okay, let me make it the bracket here. So this one is the contrapositive, this one is the inverse of our statement, and this one is the converse of our statement. Okay, now see that how easy our solutions are. Okay, so we just have to define converse, inverse and contrapositive. So basic part here to understand, first of all, define the converse of our statement, then inverse of statement and contrapositive of statement by using symbolic form. Okay, and once we get the symbolic form, then just substitute the value for our statement P and Q. What I have done, I just substitute all the values of P and Q in their statement. So I consider statement P and Q, that means statement P implies Q, it is here. Then statement Q implies P, I got it here. For converse, Q implies P, then its converse is a Q implies P, inverse negation of P implies negation of Q, and its contrapositive negation of Q implies negation of P. These four statements are very much important here for finding their converse, inverse and contrapositive. Okay, I'm expecting that you all have understood this solution. Okay, nothing is difficult. Even after if you found anything difficult, let me know in my comment section. Okay, let's move for the next example. Okay, so example, it is similar like previous one. Okay, so everywhere same question it is coming for your board exam. Okay, same question asked in, I found the most of the question paper, there is always one question, it is based on converse, inverse, contrapositive. Maybe it is coming for 3 marks or 4 marks. So we don't have to lose these easy marks. Okay, so we always have to grab these marks first, because these are the high scoring chapters. So focus on these chapters first. So we have, if it says that write the converse, inverse and contrapositive of the following statement. Okay, and statement it says that if it rains, then the match will be cancelled. Okay, so statement it is having if and then connector. So if and then connector means it is the it used here if and then, it used here if and then statement. Okay, that means if and then statement means it is the conditional statement. It is a conditional statement. If and then statement means it is the conditional statement. So when we have conditional statement, so first of all we write it into the symbolic form. Okay, now let's write it into the symbolic form. So we have statement if it rains. Okay, statement we have here if it rains, then the match will be cancelled. Then the match will be cancelled. Then match will be cancelled. Okay, so when we have rain, then match will be the cancelled. So first of all, convert our statement in the form of a logical sentence. Okay, so consider as a statement two different statements, statement P and the statement Q. Okay, now we have statement P here. If it is a rain, okay, so that means it's raining, then match will be cancelled. Okay, it is rain. Okay, it is rain. It is rain or it is raining. Okay, it's rain. Then statement, we have second part of our statement, match will be cancelled. Okay, match will be cancelled. Okay, so we have two different statement. First statement, it says that it is raining. Okay, so it is raining or it's rain, then match will be cancelled. So statement P and statement Q, two both different statements are there. Okay, now using these two statements, first of all define converse, inverse, contrapositive. Okay, so we have statement P implies Q, it's a converse, it says that Q implies P. Okay, if statement is of P implies Q, then its converse says that, let me use with some another ink so you can find it easily. Okay, if it is statement as a P implies Q, it's a converse says that Q implies P. Okay, converse what it says, Q implies P. It's not a Q implies Q. Yeah, it is taking time. Q implies P. Okay, so we have statement P implies Q, then its converse says that it's a Q implies P, and inverse, after that inverse and contrapositive. We have to define inverse and contrapositive. So in inverse, it says that negation of a P implies negation of a Q. Okay, and contrapositive, it says that negation of a Q implies negation of P. Okay, these are the four statements that we need to remember here for solving the example. Okay, these are the four examples. So do remember these statements when we have converse, inverse, contrapositive. Okay. Okay. Now let's start the solution. So first of all, we have to define here converse. Okay. Define converse. Okay. Define converse here. Okay. So converse, it says that when we have statement P implies Q, converse state that go for its reverse wording. Okay. Reverse statement. Then reverse statement, it says that if match will be cancelled, then it is raining. Okay. Okay, so what we have statement, so sometimes statement are coming quite confusing to pronouns. Okay, but most of the cases you just have to return their statements as it is given in our question. Okay. Okay, so converse, it says that Q implies P, that means if Q then P. Okay, if match will be cancelled, then statement it look like if match will be cancelled, then it is raining. Then it is raining. Okay, that means I have written converse of a statement as a Q implies P when we have statement P implies Q. Okay, let's go for the next converse. After that we go for the inverse. Okay, inverse, what the inverse states that negation of a P implies negation of Q. Okay, so it is the statement for inverse. Now let's go for the not P then not Q. Okay, so not P means if it is not raining, if it is not if it is not raining, then match will not be then match will not be cancelled. Okay, then match will not cancelled. Okay, it can be cancelled ed, because ed not to be there. Okay, we don't have to use that ed word, but it is given in our statement. Okay, yes, match will be, let me change this one also, match will not cancel. Okay, okay, this is our required converse for our statement. Okay, so what we do, first of all, we write the statement pattern, symbolic statement pattern, then after that converse, inverse, and at the end contrapositive. Okay, so third, contrapositive. Contrapositive. Okay, so what is the contrapositive? Contrapositive, it says that go for the negation of a q implies negation of a p. Okay, so negation of a q implies negation of a p. Okay, so negation of a q means if match will not cancel. Okay, if match will not be cancelled, okay, then it is not raining. If match will not cancel, then it is not raining. Then it's not raining. Okay, then it's not raining. Now see that this one is a converse, inverse, and a contrapositive of our statement. First of all, define the statement first, then go for its converse, then its inverse, and then at the end it's a contrapositive. Okay, so converse, inverse, contrapositive, these three statements here. I'm expecting that you all have understood this solution. Okay, let's move for the next question. Yes, so we have next question, which is from board exam, February 2020 board exam, for 3 marks. Okay, and question it says that state the whether statement is a converse, inverse, and contrapositive of the following conditional statement. Okay, so we have given conditional statement here as a, if a sequence is bounded, then it is convergent. Okay, if a sequence is bounded, if a sequence is bounded, then okay, we have statement as a, if a sequence is bounded, okay, then if a sequence is bounded, then it is convergent. Okay, this is a true statement from the mathematics. Okay, the convergent, I will explain the meaning for that sequence too. Okay, but let me go through this example. Okay, if a sequence is bounded, then it is convergent. Okay, then it is convergent. Now see that bounded sequence means the sequence which is having upper bound as well as lower bound, so we consider it as the bounded sequence. Okay, and that means if sequence is bounded, okay, then it is a convergent. Okay, then it is a convergent means if you have any sequence and we take limit as n tends to infinity, or we apply infinite limit to our sequence, then our sequence ends at the, or gives us the one specific point where our sequence converge. Okay, so we call it as the convergent sequence. Okay, so that means the statement pattern is true here. That means if a sequence is bounded, then it is a convergent. Okay, now we will write down the first of all statement pattern. We have statement pattern P implies Q. The statement P, it says that here sequence is bounded. Okay, write down two statements separately. Sequence is bounded. Okay, then statement Q, sequence is convergent. Okay, sequence is a convergent. Okay, so quite easy example we have here. Okay, it is asked for 3 marks in our February 2020 board exam. Okay, now let's define its a converse, inverse and contrapositive. Okay, so converse, if you have statement P implies Q, then so what is the converse of our statement? It says that, now see that if you have statement P implies Q, then converse it says that go its opposite. That means Q implies P. Okay, that means converse it gives us a Q implies P. Okay, write down into the statement form. This one is a symbolic here. If a sequence is convergent, then it is bounded. Okay, if sequence is if a sequence is convergent, then it is a bounded sequence. Okay, it is a bounded sequence. Now see that converse how it is easy here. Okay, let me change the color. Yes, if a sequence is bounded, then we say that sequence it is the convergent. Okay, and its converse gives us sequence is a convergent, then it is a bounded. Okay, now after this inverse. Okay, so if you have statement P implies a Q, then here if we have statement P implies Q, then it's a inverse. It says that negation of a P implies negation of Q. Okay, so that means inverse negation of a P gives us implies negation of Q. Okay, negation of a P implies negation of Q. Okay, here it's a inverse. We have negation of a Q implies a negation of P. Okay, so write down negation of Q implies negation of P. That means not P, then not Q. Okay, if sequence is not bounded, inverse it says that if sequence is not bounded, then sequence is not convergent. Then sequence is not convergent. Okay, CGT I written in short form. Okay, so inverse it says that when we have statement P implies Q, then its inverse says that negation of a P implies negation of a Q. So substitute the value. If not P, that means sequence is not bounded, then sequence it is not convergent. This is the inverse. Now let's go for the contrapositive. Okay, last statement. Contrapositive. Okay, so when we have statement pattern P implies a Q, then it's a contrapositive. It gives us negation of a Q implies negation of P. Now see that we have statement negation of a Q implies negation of P. Now here contrapositive it says that negation of a Q implies negation of P. So we'll add these values inside this statement. Okay, contrapositive means negation of a Q implies negation of a P. That means not Q implies not P. Okay, if sequence is not convergent, sequence is not convergent, then if sequence is not convergent, then sequence is not bounded. Then sequence is not bounded. Okay, so this one is our contrapositive of a statement. Okay, first converse, after inverse and contrapositive. Now see that this example, this type of the example carries 3 marks in our board exam. So do solve these example very carefully. Okay, so these are the scoring based chapter. And a very easy chapter there, and a question also coming very much easier. Okay, so I'm expecting that you all have understood. Let's move for the next example. Okay, now here instead of a statement we have given symbolic form. Okay, so here we have to consider the symbolic form first. Okay, that means statement P, consider here P statement x strictly less y. Okay, and statement Q here x square strictly less y square. Okay, we have two different statements here, x strictly less y and x square strictly less y square. Okay, and question asked, latest question from March 2013 board exam, 2023 board exam, for 4 marks questions asked in your board exam. Okay, so see that how easy type of the questions are coming. Okay, first of all, try to define the statement. Okay, once we come to define statement, subsequent part is easier. Okay, so define the statement first. If x strictly less y, then x square strictly less y square. Okay, that means we have here statement P implies Q. Okay, so that means we have statement P implies Q. This is our statement. Okay, this is our statement. Okay, P implies Q. Now we want the converse, inverse and contrapositive. Okay, so what is the definition for converse? So we write converse as let's write the converse. Let me change the color. Yeah, converse. Okay, if we have statement P implies Q, then we say that statement converse of our statement, it gives us Q implies P. Okay, converse of our statement gives Q implies P. Okay, so apply this definition here. Q implies P is the converse of our statement. Okay, that means statement P x strictly less y, then x square strictly less y square, then converse it gives us x square strictly less y square. Then if x square strictly less y square, then x strictly less y. Now see that how easy solution is there. Okay, just need to apply only the definition of a converse, inverse, contrapositive. Okay, let's move for the next. After that, inverse. Inverse. Okay, if we have statement P implies a Q, then its inverse, it says that we have to go for the negation of a P implies negation Q. Okay, so inverse negation of a P implies negation of Q. Okay, so what the inverse of our statement says that go for the inverse negation of a P implies negation of Q. Okay, all are the four statement given here. Negation of a Q implies negation of a P. Okay, so negation of a P. Now see that we don't have to introduce not sign here. Okay, or not word here. So it is not looking good, not word into the mathematical symbol. Okay, so instead of taking not word, we are taking directly negative meaning of our statement. Okay, so if we have statement x strictly less y, then it's opposite, completely entirely opposite of word here, x greater equal y. The value which here strictly less, we have to consider other than these values. Okay, so which is x greater equal y. Okay, now x greater equal y means we have to take strictly less as a greater equal, and if you have strictly greater as a lesser equal. Okay, that means that those values are here, we have to take all of them but other than these. Okay, okay, now see that we have statement negation of Q implies negation of P. That means negation of a Q, that means not of x square strictly less y square, that means x square greater equal y square. If x square greater equal y square, then we write negation of a Q. Okay, negation of a P. Sorry, I have written with the wrong way. Let me change this one. Okay, yeah, so negation of a P, that means negation of a P means opposite of this. That means x greater equal y. If x greater equal y, then we write then negation of a Q. Negation of a Q means x square greater equal y square. Okay, this one you need to understand. Okay, so instead of using not word, we have to introduce some mathematical symbols. Okay, So this one will be the good here for our statements. Okay, so if you're going to use not word, it's not looking good. Okay, maybe you will get the 0 marks. So be careful about this. Okay, now let's go for the converse, inverse and contrapositive. So contrapositive, it says that whenever we have statement P implies Q, we go for the negation of Q implies negation of P. Okay, so contrapositive gives us negation of Q implies negation of P. Okay, that means negation of Q. Go for the opposite. If negation of Q, that means x square greater equal y square, then negation of P, that means x greater equal y. Now this one is our required answer for our question. Now see that how easy solutions are coming. There we don't have anything in our question, just need to apply some basic definitions. Let's move for the next example. I'm expecting you all have understood. Yeah, so I have taken one another example that based on the truth table of our mathematical circuit. Okay, so we have given symbolic form P implies Q and Q implies P. Okay, so first of all, define the whether statement pattern is a truth value true or false, or both of them are coming together. Okay, so we have to define it as the whether the statement pattern is a tautology, contradiction or contingency. Okay, so question asked for 4 marks in March 2016 board exam. Okay, now what we do, first of all, define the truth table for the statement. How many statements we have here? P, Q, Q, P. That means we are having only 2 statements here. Okay, we are having only 2 statements here. Okay, so statement define the truth table. Truth table. Okay, truth table for our statement. So we have statement P, we have statement Q. Okay, statement P, it gives us 2 truth value as a tree, then 2 truth value as a false. Okay, along with we have possible chances for truth value of our statement Q. One truth value T, another false, again T, again false. Okay, one true, one false, one true, one false are truth value for a statement Q. Okay, now see that we have to solve this bracket first. That means P implies Q. Okay, P implies Q, that means implication gives us a TF as only F. Okay, so in our implication TF as a F, remaining it goes to the true. Okay, so this one is a true, TF only F, and this one is a true, this one is a true. Okay, so only in the form of an implication we get the TF as a F here. Okay, P implies Q, that means if first statement is a true, another statement is a false, means if first statement true, then second statement false, our resultant statement it comes as the value false. Okay, so similarly for another statement you can follow same here. Okay, now solve this entire bracket after this. Okay, that means P implies Q and Q. Okay, so and means conjunction always gives us the 2 truth values are true and the remaining all are the false. Okay, that means whenever we have P implies Q 2 statement, both are the true, only their statement, logical statement gives us the value true. Okay, now P implies Q and Q, apply the truth statement here between them. So T we get the truth value true, again false, again true, again false. Okay, so I got the truth table for truth values for our statement TF. How it is TF? That means P implies Q and Q, we have to use and word between of them. Okay, so TTT, at this TTT and remaining one goes to the false. Okay, now let's move for the entire bracket. So consider this bracket as, okay, let me write it separately. P implies Q and Q. Okay, P implies Q and Q. So entire bracket is having implication with the P. Okay, that means this bracket implies this bracket. Okay, so TF, find it out. TF, where we get the TF? Yeah, TF it is here F. Okay, TF gives us the value F. Okay, TF F. Okay, another all of them goes to the true. This one is a true, this one is a true, and this one is true. Okay, Now here we got the truth table for our entire statement. Entire statement we have here. So we found the truth last truth value for our entire statement as a first statement true, second true, third false, and last true. Okay. Now we have to understand the meaning for tautology, contradiction, and contingency. Okay, so tautology means our truth table gives all the values are true, then we consider it as the tautology. If our truth table gives all the values as a falsy, that means it goes to the contradiction. And contingency means it is a combination for truth value of a true as well as false. So our statement pattern, it gives us contingency. Our statement pattern, it gives us the value contingency. Okay, so I'm expecting that you all have understood my solution. Okay, don't have anything to understand here. Everything is quite easy, just need to apply some of the basic concept from mathematical logic. Okay, so let's move for the next example. Yeah, whether the statement pattern P implies Q, double implies negation of P or Q is a tautology, contradiction, and contingency. Question asked in July 2020 for 4 marks. Okay, so similarly we have more examples, only last 2 examples are there. Okay, okay, so I'll go for the little faster for solving this example. So as I have explained earlier in my previous example, we have to follow same pattern here for solving this example. Okay, so we have a statement P, we have a statement P, only we have two statement P and Q. So consider both true, both false. Okay, consider here one statement true, another false, true, false. Okay, okay, now we want the P implies Q, find out the P implies Q. P implies Q say that when we have first statement true, another statement false, it goes to the false. Okay, and the remaining all goes to the true. Okay, TF will be remain EF. Okay, and after this we have negation of P or Q. So negation of P we want it for here. Negation of P means opposite values of a P. Okay, so true value of a true, negation of a true, we get the false. Okay, that means it is a false. Again negation of a true, it comes false. Negation of a false, it gives us true, and negation of false, it gives us true. Okay, so we have negation of a P or Q. Okay, so negation of P or Q, it is the next statement. So we are trying to solve bracket first, this bracket and this bracket, then we go for the double implication. So negation of P disjunction Q. Okay, so negation of a P disjunction Q, it says that negation of P disjunction Q, so it gives F T F T T T F. Okay, so it gives F here, this one is a tree, this one is a T. Okay, in our biconditional statement, what we have here, when we have one of the statement is a false, then our implication it goes to the false. Okay, and remaining are true. Okay, so this one is our negation of P or Q statement. So we want the double implication between. So what we have done, we want the or sign. Okay, so I have taken use by mistakenly as a implication. So we have or sign here. So apply the or sign or between negation of P or Q. Okay, so disjunction between them. So negation of P or Q. Okay, or means we have F here. Okay, and remaining or goes to true. Okay, so this one is a F, remaining true. Okay, so in our disjunction we get the two statement, false statement as a false, and two in our conjunction two true statement gives us a value true. Okay, so we got the negation of P or Q. So take a double implication between P implies Q, double implies negation of P or Q. Okay, so let's go for the last table. P implies Q, double implies negation of P or Q. Okay, negation of a P or Q. So apply double implication between these two brackets. Okay, double implication gives us TF and FT are false. Okay, TT it will remain T. Okay, FF it will remain F. TT it will remain T, and last TT it will remain T. Okay, now see that our last entire column gives us all the values of our statement are true. Okay, so if all the values of statement are true, then we consider it as the statement pattern as the tautology. Okay, so statement pattern statement pattern is a tautology. Okay, I'm not writing it full sentence. Okay, so you have to understand our given statement pattern is a tautology. Okay, this one is our question from July 2022 board exam, asked for 4 marks. Okay, so I'm expecting you all have understood. Let's move for the next example. Okay, so we have the switching circuit and need to draw the symbolic form, and then we have to use the truth table for simplify our circuit. Okay, so what we do first of all, try to convert our circuit into the symbolic form. Similar type of the example I have taken already in my previous lecture. So if you are interested to see this video, you may check it into my playlist. So entire videos based on the symbolic form of our logic circuit, it is given. Okay, now see that we have two statements, S1, S2, S1 dash and S2 dash. Okay, so what do we do here? Consider S1 as a statement P. Okay, S2 as a statement Q, S1 dash as a statement negation of a P, S2 dash as a statement negation of Q. I am trying to solve this question as possible as faster, because already we have taken plenty of the videos based on this. Okay, so we're not going in detail. Okay, now first of all, see that whenever we have a series connection and whenever we have parallel connection, we have to use some of the condition for symbolic form. Okay, whenever we have series condition, we use and between them, and when we have parallel connection, we use or between them. Okay, so S1 or S2, that means P or Q. After that we have series connection, that means and negation of a P and negation of a Q. This one is our symbolic form. Okay, and further part we have to define by using a truth table, but instead of values of a T and F, we have to consider here value 1 and 0. Okay, so we have to consider value 1 and 0 and find out whether the current of our circuit flowing or not. If all the values of our truth table coming 1, that means surely current flowing from our circuit, and all the values for our statement gives us the 0, that means current cannot flow from our circuit. Okay, and if the combination for 1 and 0 both are there, that means we cannot say, or we say current flow or may not be flow. Okay, and then only bulb will be glow. Okay, when we have statement pattern all the 1, then and only then bulb can be glow here. Okay, so I'm expecting that you all have understood this my entire lecture for our today's session. Okay, so we have taken this entire lecture based on mathematical logic and previous year questions from board exam. Okay, so even after, if you found anything difficult in my today's lecture, let me know in my comment section. Okay, I will come up with the similar videos. Okay, and if you are interested to see more videos, do refer in my playlist. Okay, you will get the plenty of the videos there. And if you found anything difficult, comment me in a comment section. Okay, I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.